Good afternoon, everyone. It's another podcast series of Future Tech by Arrows Group. It's me, Charlie Sell, the MD for Arrows, and really glad to have Jamie Davey join me today. Jamie is the engineering director for Arrow Electronics, a £30 billion global engineering business, and so quite a story and a big old job there he has, and is joining us today. So welcome, Jamie.
Hi, Charlie. Hi. Thanks very much for having me on the podcast today.
Yeah, good to have you. So this series is all aimed at STEM graduates looking for roles coming out of uni. And one of the things we always start is keen to hear about your story, how you got into engineering and how you've got to where you are today.
Yeah, no problem. Thanks. I mean, for me, I have an inherent passion and curiosity for how things work, right? So that's ultimately my life is always about trying to understand, how things are put together, so the background to that. And I think my childhood was consistent of taking many things apart, understanding how they worked, and probably not being able to put them back together. But that was really the sort of the background to how I got myself passionate and engaged about engineering. The journey itself, I was fortunate enough. I studied electronic engineering at university. It was a great leap and platform into the business, and I joined at a time actually where there was a mass acceleration of component usage. Nowadays we talk about IoT, we talk about the amount of electronics that are used in everyday things. But it's been on a huge trajectory of growth since I've been in the business today. Through my role, I think we talk a little bit about what would I impart, or what would I want to share with people looking to get into engineering. My view is that it's probably the most, for me anyway, the most enjoyable space that you can be part of. It's an ever-changing landscape, an ever-changing company position that's taking place. There are a lot of movers within this space, so it's quite easy to find opportunity and to be part of something quite special, and to build businesses as well as build technologies moving forwards. I think from my own development, what you'll find is that although technology is a very broad space, there are quite a lot of niche specialist areas within it. And my main focus has always been around digital components, digital semiconductors, that drive the heart of most of the technology infrastructure that we have today. And once you get into that space, and it's maybe not apparent as you come into it as a graduate, but the market space itself for certain niches is relatively small, right? So relationships and building relationships and managing relationships within your ecosystem of people is incredibly important for your own success. And I would, if I was going to suggest something, this is make sure that you always manage your relationships on your way up, because you never know who you bump into on the way through your business life.
Yeah, because it's quite interesting, isn't it, when a lot of the podcast series that we've done so far have spoken to CTOs and other heads of engineering who come from a software background. And actually, when we're thinking about STEM graduates and a lot of the guys and girls who are studying engineering, actually understanding more about the hardware, the component parts of engineering, the actual electronics that go behind a lot of the machines and the hardware, it's a huge business, isn't it?
Oh, it's absolutely enormous. Yeah, I mean, it's a multi-$100 billion business globally of component sales. What we find is that I think what's interesting is certainly the hardware conversation, the hardware space today has become slightly less sexy compared to the software side. I think that's where a lot of the investment and money and people's time and effort has been focused on. A couple of things that I would consider that we're starting to see. We're starting to see some very interesting new developments of technology that are driving certain verticals, such as vehicle electrification, for example, which is very hardware dominant. I mean, there is vast amounts of electronics in there for the automotive, with the driverless car automation and the actions behind it. But you still need to have battery technology. You still need to have motor drive technology that is super efficient to make this all work, as well as a very high compute level to be able to make an autonomous vehicle operate, right? And so all of this does need a complex hardware system to deliver that.
Yeah, because I know we've spoken previously about Industry 4.0, haven't we? And just how automation is going so much further than standard manufacturing. And you mentioned earlier when we think of Internet of Things, automation of machines and driverless cars, electronic vehicles. And of course, you're totally right. The hardware aspect is without that, the software just can't run, I guess.
Yeah,
So,
well, yeah, you always need a bit of hardware to run your software. Absolutely. I mean, I think my view, Industry 4.0 is now gaining significant momentum, if that makes
yeah,
sense. And we had sort of I guess, a buzzword of IoT for the last 5 years, maybe even slightly longer. We're going to see a lot more Industry 4.0, as part of our activity. And think about why that might be driven, by the way. We're seeing a lot of barriers about globalization, borders being strengthened, unfortunately, I think, for the transit of goods and services. And even through this pandemic, I mean, I've been talking to a large number of our largest clients out there, and I would say that a lot of them are thinking about onshoring the design and manufacture of their products, and of course, to compete with the prices of lower cost countries and lower cost regions, they're going to have to do heavy automation of those builds and build packages as they onshore them back on. So to deliver that, you're going to need complex robotics. You're going to need, complex manufacturing systems communicating with each other. Sorry, to fully automate that build process.
yeah, yeah. So when we're thinking about graduates, is what this podcast is aimed for, would you recommend, in your personal opinion, that people should be absolute specialists within a specific engineering field like robotics, or do you think people need a blend of understanding both software and hardware for their future job roles and what the market will ask for people?
Yeah, I mean, that's a really good point, actually, Charlie. I think that you must understand the wider context that you operate in. As somebody in technology, as an engineer, however you want to describe what you do. I think the key thing there is that there are going to be specific areas that require a deeper understanding of all of those things, if that makes sense. So if you were looking at robotic design, you need to understand the hardware software model of how it works. Maybe compared to, say, if you were looking at AI camera analytics, for example, you may not really care so much about how the camera operates. You care about the images and that come off the camera and how you're going to run some AI algorithms on those end solutions. So it sort of depends which field you're in. But my view would be, whichever field you are in, become a high expert of that particular field, but have a good understanding of the broader space that you fit.
Yeah, no, I couldn't agree with you more. It's, again, from a software side, we look a lot at polyglot engineers now. So people studying a development language, and no longer is it becoming a specialist in one single language. It's being able to develop across a full stack range, essentially. And I think that understanding from an engineering perspective is quite similar, isn't it? You have to appreciate the other parts of the engineering process, even if you specialize within one part of it.
One area. Absolutely. Yeah. I mean, so from purely from the hardware domain, I mean, not only now, so we often split then into multiple disciplines across that group, if that makes sense. So we would have to have, if we were talking to a client, we'd have wireless specialists, we'd have FPGA specialists, we'd have power experts, for example, and all these are quite different disciplines, right? So the teams will be able to understand contextually what each other is talking about, but it'd be very difficult for one to step in the other one's shoes and deliver the solution through that, right? So I think that is key.
Yeah, great. So thinking, your views, you've seen graduates come through the ecosystem, I can imagine, and you've probably got quite a clear view of the strategy. Where, if you were to speak to, the next graduate pool and they ask you the sort of direct question of where you see the job market in 5 years' time, have you got a thought of where the evolving jobs are going to appear?
Yeah, I mean, I've got a view where I think the market's certainly going to have massive growth, and whenever there's massive growth, you need engineers to support the design of those moving forwards. I mean, if you think, in fact, the global environment now with COVID has only accelerated this, but certainly the whole EV market, the whole electrification, not just of cars, but let's also think about any mass transport too, right? So we're having the same conversations about bus companies, about trash recycling and how that's picked up. We were talking about rail networks. You know, all of them are driving towards a cleaner solution that's being delivered on that space. I mean, some other areas I would certainly look at would be around the whole industry 4.0. I think we touched on that before.
Yeah.
We still see a lot of robotics and connectivity within that space and how that's being built out. I wouldn't underestimate where we're going to go with machine learning and machine learning within a hardware environment rather than maybe on the cloud or so basically edge compute, but with machine learning, AI algorithms running at that level. So we're going to there is tremendous opportunity within the space as you move forwards there.
Yeah, great. And so I suppose last question, and it's more words of wisdom from someone who's been a grad all the way through to where you are today. Any lessons learned, any tips or a bit of fatherly, that's the wrong word, but guidance, I guess, for the next generation?
Yeah, I mean, so a couple of things I would say is, we're fortunate that we have a pretty aggressive or a pretty big graduate program that we run inside of Arrow across globally, actually, across Europe as well as worldwide. And where I see the difference between the excellent graduates that come into the team and ones that just succeed are the ones that feel confident enough to engage, very quickly with the rest of the team. So, spending that time and it can feel a bit challenging, especially, not everyone from an engineering background is an extrovert, right? So they may have to spend a bit of time, making connections with people, but making those connections early within the business and not just within the frame of or the team that you might be in, but actually making it across the wider part of how a business operates is going to be absolutely crucial to your own success. I think that's what is often misunderstood, that you join a department in a business, whatever size it is. I mean, ours happens to be quite big, but we've got a lot of other departments that all have to operate together to be a successful go-to-market engine. And you need to understand not just about the engineering aspects of it, but also understanding the business context that you operate in, right?
Yeah.
And I think then just one last thing I would say, just be curious about everything that you touch, be it a business process, be it an engineering problem or solution, just think about, how you can inject a level of curiosity about it so that you understand it in detail, and then you can add some of your own thoughts and wisdom to it.
Yeah, no, fantastic. I think I totally agree with you. I mean, that's a transferable skill set for all graduates, isn't it? Relationship building and curiosity, making sure you fully embed yourself in any company, any industry that you join, and trying to be as visible and add as much value as you can is not a truer word could be said. Brilliant. Well, look, thank you. What a great, really insightful. And so that's another program for the Future Tech podcast series. So I hope you'll enjoy it and look forward to seeing you and you hearing it for the next one. Thank you, Jamie. Really appreciate your time.
No, thank you. Thanks so much. Thanks very much, by the way.
Great.